name is Joseph Sanchez. I'm a systems engineer on the system design and mission assurance team. We're here at Altamont, which is our test track where we take our vehicle, expose it to real-world scenarios, and evaluate its performance and iterate on its performance. How's the flash going?
Another 10 minutes and we should be good to go.
My name is Jasmine Perez. I am the Demo and Milestone Program Manager. We are testing a new software feature. We will stress test on the track and we'll put our vehicle through a couple of test cases to validate that software before we release it to the rest of the fleet.
Track control is B102 requesting access to the track.
My name is Zaihao Wang. I work as a verification and validation engineer in the system design and mission assurance team. And my main responsibility is to design a rigorous test program to ensure safe operations of our robots. Our team plays an important role in defining what to test, how to test, and what to expect. We have a philosophy. We test what we simulated, and we simulate what we tested. So before we do a structured test, we do a lot of homework in simulations beforehand.
My name is Chris Wong. I work within perception team under software org. My teams write code to detect collisions. The simulation side and the structure test, they are really the fundamental tools that help us to validate the software we build.
My name is David Casterton. I manage the Simulation Scenario Frameworks team. Generally speaking, at Zoox, to meet our safety bar, we need to identify and analyze potential safety risks as early as possible in the development process. In simulation, we can exercise parts of the software stack in a highly scalable fashion very early in the development process, without letting potential safety risks manifest in the real world. This gives our teams a way to rapidly develop new features.
I'm Anas Lasram. I'm a software engineer in the simulation team. Many teams at Zoox use simulation. It is a key method to identify and analyze potential safety risks, and it's scalable. Anybody across the company can access Scenario Editor. They can define scenarios. Everything we do at Zoox, we try to do it in a safe environment in simulation before we actually test on vehicle.
I'm Angelika, and I'm a senior technical program manager in the PMO team here at Zoox. I would say PMO is like the music directors in an orchestra, as I would say, where you're bringing all these world-class experts and amazing musicians together to create something beautiful. And it has to be a well-coordinated performance. We work with the teams to help them identify what are the corner cases that they would like to test for structured testing, which otherwise you cannot fully explore on a system-level integration asset or a bot-level testers.
So today we're setting up for a planner test where we want to run the vehicle in a fully autonomous mode on the track. So we want to try to recreate the scenario as best we can.
My name is Abhishek. I work as a software engineer on the planning and control team. The scenario that we came up with is this agent in an oncoming lane trying to cut us off in the brake in front of us. So once we have that idea, then I go over to somebody on the QA team that works with Sim, and they're going to create a simulation scenario that we can then run our code on and validate against before we have to put it out in the real world.
Hi, my name is Shiva Rollins, and I am a release manager on the software release management team. Our vehicle operations team executes a number of structured scenarios on our test track. We stage scenarios and we test them from release to release to make sure that there aren't any regressions compared to the previous release.
My name is Allison Heredia, and I'm a AI verification and validation engineer for the System Design and Mission Assurance team, which is SDMA. My team's involved in every step of the structure testing, from figuring out what is it that we actually need to test on vehicle, from looking at our simulation results, and also looking at what different new software features are coming down the pipeline, to designing those tests themselves, being here on site to set up, coordinate, and lead the testing day, data analysis, all the way through to reporting and figuring out what that means for our next steps.
Vehicle's gonna be moving, everyone. GSC is ready.
My name is Yvan Lemongo. I am part of the Systems Design and Mission Assurance vehicle test teams. This scenario does a couple things for us. Primarily, this is a situation that you can imagine even as a human driver that you might encounter with potentially aggressive agents. So you want to make sure that the vehicle is capable of exercising this kind of defensive driving behavior where it's able to recognize and predict that there's an agent that's going to enter a potential path of collision with us or just enter our traveling path and react accordingly. So in this case, we want to make sure that the vehicle can recognize that the agent is coming and brake for it, but not just stop, but also continue on its mission in this case if the situation shows that it's the safe thing to do. As you've seen in a lot of the runs that we've had, that's exactly what happened. The agent merged over, the vehicle was braking enough to restore the gap distance, the following distance between the two. And eventually in a couple of scenarios where the agent was getting too close, we had that collision avoidance system kick in and make sure that the vehicle stops completely to avoid a collision.
For data analysis, what we're looking at depends on the case, but oftentimes, especially if it's involving agent testing, we want to be making sure that the vehicle is behaving the way we expect it to based on simulation and what the feature is intended. So we'll be looking at those interactions with the agents, what velocity and deceleration rate our vehicle has, how close we get to those agents, making sure we're always within our safety margins.
Then we come back and do a lot more work looking frame by frame how good our software is handling those scenarios. Are we expecting what we are expecting? So then in this way, we can improve our software, trying to see if we can do better. And then you try out on your simulation, and then maybe on the next vehicle test, in the structure tests on the track, you try it again. Or you try a different scenario with a different variation. So this is going to be an iterative loop.